Welcome to channel Mathematics Videos. Today we are going to solve question 40 through question number 50 of the exercise 2.2 of the text Calculus by S.M Yusuf. Question number 41 and question number 42 are of the same kind, and I will prefer to solve the question number 41. And this is cos inverse hyperbolic 1 plus x square. You have to differentiate these functions with respect to x. So we will assume that this function is equal to y. Next we will differentiate straight away. You must be pretty familiar to the derivatives of inverse hyperbolic functions, and derivative of cos hyperbolic inverse 1 plus x square has to be determined in the next step. This happens to be equal to 1 divided by square root the angle square, or the element upon which the cos hyperbolic inverse is being applied, its square minus 1. And what is that expression? And that expression is 1 plus x square, obviously. We have just used the definition of derivative of cos hyperbolic inverse, and we have to differentiate this quantity. Next we have to just simplify it. Plus 2x minus 1, 0 plus 2x, x square is going to be taken common, and it is x square plus 2 times 2x You can separate the square root. This is rather very easy question, therefore I am not going in so much of the details of this question. In plenty of time I have already told you that square root x square, it is equal to absolute value of x, because both of these functions have the same characteristics, they are equivalent. absolute value of x times x square plus 2, and the 2x has to be written at the denominator, and it is the answer of your question. Question number 42 is of the same kind, and this has to be done by yourself, and I will solve out the question number 43. Question number 43 is square root x plus square root y equal to square root a. Differentiate both of the sides. You will get 1 by 2 square root x multiplied by the derivative of x, that is 1, plus 1 by 2 square root y multiplied by the derivative of y with respect to x, that is dy by dx, is equal to derivative of a constant that has to be equal to 0, and obviously dy by dx times 1 by 2 square root y is equal to negative of 1 by 2 square root x, and by eliminating dy by dx from here, you would get square root y divided by square root x and a minus sign, and this is obviously equal to negative of square root y divided by x. That is the answer of your question. The next question is question number 44, which is similar to that of 45 and 46, and therefore I will just solve question number 45 and question number 46. Question number 45 is x cube plus y cube minus 3axy is equal to 0. Differentiate both of the sides, and without going into too much of the details, I will just write the answers of the derivatives of each term. Power rule, minus 3a, and here we are going to use the product rule. When product rule is applied on the product of x and y, you would get the derivative of the first term, that is x. Its derivative is 1 times the other, that is y, plus x times the derivative of the second. Simplify it, and this is equal to 0. 3x square plus 3y square and minus 3ax. You have taken dy by dx as common between the various expressions. Minus 3ay is equal to 0. Shifting the other quantities, this quantity and this quantity, towards the other side, 3ay minus 3x square whole divide by 3y square minus 3ax times dy by dx, and this coefficient has to be transferred here, and you will get the final result. Three y square minus 3ax. So in the next time you just have to take a 3 as common between numerator and denominator, and the result is ay minus 3 x square divide by y square minus 3ax. Let me check the answer. Yup, it is the correct answer. Now we will solve question number 46. The rest of the exercise is very easy, and I don't think that any of the questions is so much important from the viewpoint of the paper, but conventionally I have to solve most of the questions because it is possible that they would come in your examination. Next we will solve the question number 46. And it is x square plus y square cube whole cube is equal to y. Differentiate both of the sides with respect to x. You have to apply the power rule on the left hand side. 3x square plus y square whole power 3 minus 1, that is 2, times the derivative of the base quantity, that is x square plus y square. Its derivative is the x plus 2x plus 2y, the derivative of y with respect to x, dy by dx, and it is equal to dy by dx. Apply the distributive law. 3 times 2, that is 6x times x square plus y square square, and similarly plus 6y x square plus y square times dy by dx is equal to dy by dx. Shift this quantity to the other side and bring that one to here, and take dy by dx as common. You may find minus 1 and 6y times x square plus y square whole square to be equal to minus 6x x square plus y square whole square and in the next step bring this quantity here and it would be your final result 6y times x square plus y square whole square minus 1 and remove it from here. Let me check this answer to question number 46. Yep, it is the answer. Next we will solve the question number 47. Question number 47 is pretty similar to that of question number 32 of the previous lecture. So you may have to solve it by yourself. So I will solve question number 48. If there is any problem regarding to question number 48, 47, you will have to ask me in the comments below of this video. Question number 48 is arc tan x plus y, that is tan inverse x plus y is equal to arc sine e raised to the power y plus x. Differentiate both of the sides by using the corresponding rules of inverse trigonometry. You may find the derivative of inverse tangent function is 1 plus square of this quantity upon which the tan inverse is being applied whole square times the derivative of the same quantity d by dx of x plus y and same has to be applied here. 1 divided by square root 1 minus x square, e raised to the power y plus x square times the derivative of e raised to the power y plus x. Simplify these both of the sides further. You might find 1 divided by 1 plus y whole square times 1 plus dy by dx. This happens to be equal to 1 divided by square root 1 minus e raised to the power y plus x whole square times the derivative of exponential functions has to be applied here. E raised to the power y times the derivative of the power with respect to x plus derivative of x with respect to x, that is 1, apply the distributive law of multiplication over addition here. plus 1 divided by 1 plus x plus y, it was, sorry, x plus y whole square dy by dx is equal to e raised to the power y divided by square root 1 minus e raised to the power y plus x square dy by dx plus 1 divided by square root 1 minus e raised to the power y plus x whole square. Bring the dy by dx term towards the left hand side, and you're gonna find that 1 divided by 1 plus x plus y square and minus this coefficient e raised to the power y whole divided by square root 1 minus e raised to the power y plus x whole square, and shift this quantity to the right hand side, and by shifting it towards right hand side you may find 1 divided by square root 1 minus e raised to the power y plus x square minus 1 divided by 1 plus x plus y square simplify it. You may find 1 minus e raised to the power y plus x whole square minus e raised to the power y times 1 plus x plus y whole square, and whole is divided by the LCM. 1 plus x plus y square times square root 1 minus e raised to the power y plus x whole square. You may also have to simplify it here. You obtain 1 plus x plus y whole square minus a square root 1 minus e raised to the power y plus x whole square, the LCM technique that is applied to the left hand side. The same is applied here on the right hand side. 1 plus x plus y square, x plus y whole square times 1 minus e raised to the power y plus x whole square square root this whole term is cancelled by this one, and there is some mistake. I think yes, there was dy by dx, and you have to bring this quantity, that is the coefficient of dy by dx, to the denominator of this quantity on the right hand side. 1 plus x plus y whole square minus square root 1 minus e raised to the power y plus x square whole divided by square root 1 minus e raised to the power y plus x whole square minus e raised to the power y times 1 plus x plus y whole square. Let me check the answer. Yes, so it proves to be the answer of your question. Next question is question number 49, and it is a very simple question. Y equal to arc sine ln x minus ln tan inverse x arc tan x dy by dx is equal to, apply the differentiation with respect to x on both sides. The derivative of sine inverse x is, everybody knows that it is equal to 1 minus x square, and instead of x here is ln x square, that is ln square x or ln x square multiplied by the derivative of the quantity upon which the sine inverse is applied. It is ln x and its derivative is 1 divided by x minus, next you have to apply the rule of derivatives of natural logarithms, and it is 1 divided by the quantity upon which the natural log is applied. So 1 divided by tan inverse x times the derivative of this quantity upon which the log is being applied. It is tan inverse x, and its derivative is 1 divided by 1 plus x square. So this is the answer of your question. Just in the next step you need to combine this is the answer of your question. This was a very simple question, and it is not so important from the viewpoint of the paper. Last question of today is question number 50, and it is y arc sine x minus x arc tan y, that is tan inverse y, it is equal to 1. Directly apply the differentiation. You have to apply the product rule here and the product rule here. First we will apply the product rule on the first expression. Derivative of the first quantity times the second expression plus second expression first expression as it is, and the derivative of the second one. Sine inverse x, its derivative is 1 minus x square root times the derivative of x, that is 1, needs not to be written here. And in the next you have to apply the product rule on the second quantity. So please hang on for the notification being removed. So apply the product rule on the second quantity. The derivative of the first term times the second one plus first term as it is, the derivative of the second one, tan inverse y. It is 1 divided by 1 plus y square times the derivative of y. You should be familiar to the derivative of inverse tan functions. Derivative of 1 is 0. Further simplify and bring out dy by dx quantities together. The first one, the first dy by dx has coefficient sine inverse x, and the second one has minus x divided by 1 plus y square. And you may have to shift these two quantities, this one and this one, towards the other side of equality, and you may find minus 10y. When it goes to the other side, it becomes plus 10y, and tan inverse y, and minus y divided by square root 1 minus x square. Simplify it further. You might get square root 1 minus x square. The LCM method has to be employed here. Tan inverse y minus y whole divided by square root 1 minus x square. Same has to be applied here. You might get 1 plus y square times sine inverse x minus this quantity x whole divided by the LCM, that is 1 plus y square times dy by dx. In the final step you have to apply the cross multiplication. And you would get the final result, 1 plus y square multiplied by the numerator, that is square root 1 minus x square times tan inverse y minus y, and whole divided by the denominator as it is, 1 minus x square 1 minus x square square root multiplied by this quantity, that is 1 plus y square sine inverse x minus x. So today's lecture was quite simple, and to me it was very naive and not so very important from the viewpoint of the paper. So thanks for watching.